Hello, Matthews Gatos here. In this lesson, lesson number 10, I am going to be doing all the questions of your practice test. So you can pause the video, to fast forward it, rewind it, whatever you need to do, go to the questions that you need help with. I'm going to do them all. So let's start with question number 1. It says the exact value of log base 4 of 16 is what? So when I evaluate a log, I'm really asking myself 4 to what exponent gives me 16? And that is 4 squared. So the value of this log would be 2 because the value is the exponent. Okay, magnitude of an earthquake is 100 times as intense as an earthquake with a magnitude of 5.5 on the Richter scale. So we want to figure out what the magnitude of the other one is. So the magnitude of an earthquake is 100 times. Okay, so we're trying to find the one that's more intense. So because 100 is like 2 factors of 10, or 10 squared in intensity, I know that the earthquakes are going to be a factor of, or 2 units apart. So if it's 5.5, I'm going to add 2 onto that to get 7.5. So a difference of 2 units makes a difference of 2 factors of 10 times intensity. So it has to be a 7.5. Okay, next one. If 2 log base n of x equals 16, then what is x equal to? So let's look at this. Very first thing that I want to do is isolate for my log. So I'm going to divide both sides by 2. So I have log base n of x equals 8. And then I'm going to use circle of logs and switch it into exponential form. So n to the 8 will equal to x. So n to the 8 equals x. And then my option answer is A. Okay, number 4. Population of an Alberta town is decreasing at a rate of 5% per annum. So I know my base is going to be less than 1 because it's decreasing. So it's going to be 100%, which is all, minus the 5%, which it's losing. And that means it will be 95%. So the base is going to be 0.95. So I can knock off this and this as a possible answer. So 95% as a decimal. Okay, the current population is 2,500, so that's your A value. So current population is 2,500, so I can knock this off as an answer, so it has to be D. Let's just finish the rest of the question to make sure. Which equation can be used to determine the number of years required for the population to reduce to 15,000? So that's your end amount, which is right there. So yes, D is in fact the answer. Okay, the approximate value of log base 5 of 31. Okay, so you could just put this into your calculator, but they're intending this section here to use without a calculator, just to review some of the rules of logs that we've done. So let's listen to that. So log base 5 of 31. So the base is 5, so let's think about powers of 5. So you can have 5 by itself, 5 times 5, which is 25, 5 times 5 times 5, which is 125. So this argument of 31 is in between 25 and 125. So this is 5 squared, this is 5 cubed. So I know that the value of the log will be in between 2 and 3, but much closer to 2 because 31 is much closer to 25 than 125. So this would be my answer here. Okay, next one. If log base b of p equals 4 and log base b of q equals 2, then what is the log base b of p and q cubed? Okay, so what I'm going to do is go to my log here and I'm going to expand it. So when I multiply arguments together, I can expand that by adding the individual logs. And then of course the 3 will come down. So I have log base 6 of p plus 3 log base b of q. So log base b of p is just 4, so I can replace this with a 4. Log base b of q is a 2, so I can replace that with a 2, and then I'll multiply. So what I really have is 4 plus 3 times 2 is 6. So this whole value will be 10. So my answer is 10. Okay, so I guess we can use a calculator for the remainder of the test. I won't do that on your tests, but it's good to do some of these questions without a calculator just to review some of our basic facts. So we have 8 to the 2x minus 1 equals 216, and we want to solve for x to the nearest hundredth. So if this was a question on my test, for 1 mark, I wouldn't solve this algebraically. I would do y1, y2, and then do the intersect. Okay, so I'd put this side here into y1, I would put this side here into y2, and find where they intersect for just 1 mark. But I want to show you how to do this algebraically because it would be a nice chance to review that. So looking at 8 and 16, go to the smallest base, which is 8. I cannot write 16 as a power of 8, so I'm going to go even smaller. I'm going to go to a base of 2. So I know that 8 is the same as 2 cubed, and 16 is the same as 2 exponent 4. So 8 here, 2 cubed, is raised to the 2x minus 1. So I will raise this to the 2x minus 1. And then 16 is all by itself. So I have 2 multiplying my exponents, 6x minus 3 equals 2 to the 4. And then I will drop my base, and 6 minus 3 equals 4. Add 3 to both sides, and divide both sides by 6. So I get 7 over 6. And that to the nearest hundredth is 1.17. So that would be my final answer. Okay, for this next one here, log base 25 of x equals 5. What is the value of x? So I'm going to use circle of logs here, just like that. So I'm going to have 25 to the exponent of 5 equals x, and that makes D my answer. Okay, number 7, expressed as a single log. Okay, so first of all, any numbers that are in front come up to be exponents. So I know that q is going to have an exponent of 4. So it'll be log of p minus log of q to the exponent of 4 minus log of r. So looking at these, I'm going to get rid of anything that does not have a q exponent 4. So like this one and this one can go away. Okay, now combining them together, I am dividing. So when I subtract logs, I can divide the arguments. So this is going to be p on top divided by q exponent 4. And if I'm dividing by r, the r is also in the denominator because I'm dividing by all of them. So this would be your answer. Is that right? Oh, no, that's an r on top. Oops-a-daisy. This would be your answer. There we go. Pick the one that matches your answer, Gatos. Okay. Let's look at number 8. So p over q equals 25. What's the value of log base 6 of p minus log base 6 of q? Okay, so I'm going to look at these logs here, which are subtracted, and I'm going to combine them by division. So log base 6 of p over q. And p over q is 25. So I'm going to replace p over q with 25. So replace this with 25, and I will have log base 6 of 25. So I can just evaluate that on my calculator, log base 6 of 25. And when I evaluate that on my calculator, I'm going to get 1.80. So just so that I make sure we're all okay on how to do that on your calculator, let's just go in here. And I'll show you, regardless of the calculator that you're using, how you can go ahead and do that. Okay, so if you have an 83, you evaluate this by going log of 25, close your brackets, divided by log of 6. So log of the argument divided by log of the base. And you get 1.8. If you have an 84 or newer, we're going to go math, alpha, math to get the log template. And then I just put in a 6, and then I go over here to put in a 25. Press enter, and I get the same answer. Okay, so that's how you evaluate it on your calculator. Okay, number 3. So in the equation, log base x of 64 equals 2/3. What is the value of x? So I am going to do circle of logs. Just like that. So x to the 2/3 equals 64. Now, when we have something like this where we have a rational exponent, I showed you guys to raise it to the reciprocal power, 3/2. Raise the other side to be fair to the reciprocal power, because then 3 divided by 3, 2 divided by 2, you're just left with x. So 64 to the 3 over 2 is just saying it is the square root, because the 2 is in the denominator, of 64 cubed. But again, you could just put that into your calculator, and in doing so, you would get 512. So to do 64 to the 3/2 on your calculator, 64 to the exponent of, now if you have an 83, it doesn't go up like that. You would put it in brackets and just do 3 divided by 2. And you would get that as your answer. Okay? Okay, so number 9. The value of log base 6 of y equals t. The value of log base 6 of 36y is what? Okay, so work on the bigger one that we have here. I've multiplied my arguments so I can separate them into two different logs by adding. So this will be log base 6 of 36 plus log base 6 of y. So log base 6 of 36 is just a number. 6 to what exponent gives me 36? That's a 2. Plus log base 6 of y, we said right there that that was just equal to t. So it will be 2 plus t, which means d is my correct answer. Okay, number 10. So a student is attempting to solve these equations. The work is shown below. We need to find out if they made an error or not. Okay, so it looks like what they started to do is they took the log of both sides. And they're probably doing this so they can get the exponents down, so that's good. So they bring the exponents down, and right away I'm a little suspicious because I always tell you guys to put brackets around it. And looking at that, yes, they didn't put brackets around it. Because they didn't put brackets around it, they thought that the log 5 just went with the 2. But the log 5 is a number, and it actually gets distributed into the brackets. So you see the 4x here is missing the log 5. And over here, the 3x is missing the log 3. So actually they made the mistake right in the very first step. Okay, a privately owned music store is selling all of its compact discs, so it can focus on selling DVDs. During the first week of the sales, all the compact discs are priced at $18, so that's your initial value. So my initial value is $18. And each week, the compact discs are reduced by 12% of the previous week. So that means my base is going to be less than 1. It's going to be 100% all of it, minus the 12% I'm losing from week to week. So that's 88%, but we need to put that as a decimal, 0.88. Determine the during the 7th week of the sale, the price of the compact discs will be what? Okay, so during the 7th week, we are starting here, our very first reduction. Let's just think here. We're going to put this into our equation. Y equals a times b to the x. So 18 times my base of 0.88, and that will be to the exponent of x. So the tricky part here, and it doesn't sound like it would be a tricky part, is actually your x value. So if we look at this here, if x was 0, it would be at the beginning of the week, and it would just be $18. And if x is 1, it's actually the next week, which is technically the 2nd week. So during the 7th week would actually be 7 minus 1 is 6 different cycles. Okay, so we have our original price, and then we're going down by each time. Okay, so I'm going to put this into my calculator as 18 times 0.88 to the exponent of x. Okay, another way that we can look at that, because we can just plug that into our calculator, let's just look at if I were to go into my table of values. I just want to show you that. So I'm going to clear this out. So 18 times 0.88 to the exponent of x. Let's just start our table at 0. There we are. So if time was 0, that's like before it goes on sale, right? So there it's $18. Now it says that each week that it doesn't sell, it goes down by 12%. So during the 7th week, well, this is actually the 1st week. And if it doesn't go on sale, when x is 1 is technically the 2nd week. So in the 2nd week, it's this. Okay, so here we have the 1st week, 2nd week, 3rd week, 4th week, 5th, 6th, and 7th week, you can see that my x value is in fact 6. Okay, so sometimes at the table of values, it's easier to see that. Okay, so it's going to be worth $8.36. So putting it into your calculator using the table, or just putting it into your calculator on the main screen. Either way, though, we see that D would be the option. Okay, Jane would like to visit her family in Australia. She figures that she will need at least $9,000 for the plane ticket and expenses. She goes to a local bank in Calgary to open a savings account. After some thought, she decides to deposit $7,500 into an account. Okay, that's your initial value, that's your A value. That pays 6% per annum compounded quarterly. Okay, so I can tell you right away looking at this question here, because it is compounded quarterly, you guys would not have a question like this where you have to come up with the formula. So I am actually going to omit this question here because they don't give us a formula. You are only going to do questions that are compounded annually. So I'll cross this question off because they didn't give us a formula. Okay, let's see if number 13 is better. Okay, so this one here is compounded semi-annually. So because it's not annually, they have to give us the formula. That's part of the curriculum, so I'm going to cross this question off as well because we don't have a formula. Okay, let's look at this one here. A ball is dropped from a height of 5 meters. After each bounce, the ball rises to 75% of its previous height. So notice it's not saying it increases by 75% or it decreases by 75%. It is actually 75% of its previous height. So that means the base is just 5.05. Now it's dropped from a height of 5 meters, so that's my A value. So my equation right now is looking like this: 5 times A to the x. So the maximum height of the ball in meters after it hits the ground for the 6th time. Okay, so if it's going to hit it for the 6th time, that means that x is equal to 6. So I can just say that it's 0.75 to the exponent of 6. So I would just put it in my calculator because that's a number. So it would just be like this. So I go 5 times 0.75 to the exponent of 6. And then there it is, 0.89, right there. Okay, number 14. The number of bounces it would take for the ball to reach a maximum height of approximately 5 centimeters. 5 meters, 5 centimeters. So the first thing I need to do is change that. They need to be the same unit. So 5 centimeters is the same as 0.05 meters. Okay, so I want to know when is it going to be 0.05 meters. So this is an example of y given x needed. So what I'm going to do is I'm going to do this. I'm going to have my original equation in y1, and in y2 I'm going to have 0.05, and I'm going to use y1, y2 intersect to figure out the number of bounces. So let's go into our calculator, and in y1, let's clear that out. I'm going to put 5 times 0.75 to the x. And then in here, I'm going to put 0.05. Now these are really small numbers, so I'm going to adjust my windows to kind of help out with that. So x is the number of bounces. So we can have 0 bounces up to, let's try 20. We'll go up by 2s. Y is your height. Now I'm dropping from a height of 5%, and I'm never bouncing over that. So I'm going to go just from 0 to 5, and I'm going to go up by, say, 0.5s. Let's see if that will be good enough. Okay, so there it is decreasing. Oh, there's 0.05. You can just kind of see it along there, and let's find the calculation, the intersection. So second trace, option number 5 for intersect. And we'll go enter, enter, enter. And there we go. I get that it's going to be 16 bounces. So back over here, I can say that the answer is 16. Okay, the formula, goodness gracious, look at that formula. Used to compare the intensity of 2 sounds measured in decibels. How many times more intense is a student talking at 60 decibels compared to 30? I am not going to use that. Let's use our little shortcut. So remember, sound is Graham Alexander Bell, so we need to put them into bells. So just divide them by 10. So this is 6 bells and this is 30, so it's 3 bells. Okay, so if you look at this here, the 6 bell is 3 units higher than the 3 bell sound. 6 take away 3, it is 3 units higher. So it means that the intensity will be 3 factors of 10 more intense, or 10 times 10 times 10, 1,000 times more intense. Okay, let's look at the pH scale. So if lemon juice has a pH value of 2.5, so it's like right about here, lemon juice, pH of 2.5. Then to the nearest whole number, how many times more acidic is lemon juice than tomato juice? And it looks like tomato juice has an acidity of 4. Or sorry, pH of 4. Okay, looking at this question, let's use our little shortcut that we do. There we are. Okay, so comparing these two here, the pH of 4 is, and compared to the pH of 2.5. So acidity, it's more acidic the lower the number is. So this pH of 2.5 is more acidic than this pH of 4. So the difference between those is 1.5 units different. And I do that by doing 4 take away 2.5. So remember, pH is the one that's a little trickier. You just have to subtract in the direction of the acidity. Okay, so that means that it will be a 1.5 factors of 10 times more acidic. So that would be 10 to the 1.5. Put that into your calculator and you're going to get like 31.6227, etc. So it's going to be to the nearest whole number 32 times more intense. Okay, next one. Solution X has a pH of 9.2. Solution Y is 20 times more alkaline than solution X. Okay, so it's more alkaline, and alkalinity, or moving in the basic direction, it's a higher number. So if this solution here is more alkaline, it's a higher number. So we need to find the difference between Y and 9.2. So that unit change is going to correspond to an intensity change. So the intensity level is 20 times. So normally we're solving for that, like the last question, but this time we're solving for the pH. So intensity factor of whatever Y is on the pH scale minus 9.2, that is going to equal to 20. So a couple choices that I could do. I could do this in my calculator, left side in Y1, right side in Y2, and it's just a Y1, Y2 intersect. So I know you guys know how to do that, so I'm going to show you the other way of doing it. When I have one power, I would just switch this to log form with Bay. So this is going to be log of B stands for the base, which is just base 10. A stands for answer, E stands for equals exponent. And then all I would have to do is just add that 9.2 to both sides. So I know that Y is going to equal to, now log base 10, that's just a common log. So I could just write that as log of 20 plus 9.2. And then I can just put this into my calculator. So log of 20 plus 9.2. So let's get out of here. I'm just go log of 20, make sure I close my brackets, plus 9.2. And I'm expecting to see a higher number than 9.2 because it's more alkaline. And there we go. I get 10.5. So I can put that back into my notes here. So this would be a pH value of 10.5. Okay. So the exact solution of this here. So again, you could do this on your calculator by figuring out what the solution is. Y1, Y2 intersect, and then just see, to solve for X, to see which one of those has the correct answer. But I'm going to do this algebraically, just as a nice little review. So there is that option to do it on the calculator. So if I did this here, I am going to take the log of both sides to bring my exponent down. So when I take the log of both sides like this, I can bring the exponent down in front. But remember, when I do that, I need to have brackets around whatever I'm bringing down, so we don't make a mistake like that last question we saw. So I've got 4x times log of 2 equals, in brackets, x plus 1 times log of 3. Now, remember log of 2 and log of 3, they're just numbers. So just like I would treat this if it was a 2 and a 3, I would multiply it in together. So I have 4x log 2 here, nothing to do there. And then I'm just going to distribute these in. So I have x log 3 plus log 3. So anything with an x term, I'm going to get on one side of the equation. Anything without an x term, I'll keep on the other side of the equation. Okay, so what I'm going to do is I'm going to subtract x log 3 from both sides. So I'll have 4x log 2 minus x log 3 equals to log 3. Now that I've got all my x's together, I will factor out an x. So factor out an x, and I'm left with 4 log 2 minus log 3 equals log 3. And then divide both sides by that number. So x is going to equal to log 3 on top, and 4 log 2 minus log 3 on bottom. Okay, so that would be A as my correct answer. Okay, let's look at this one here. So we have exponential decay used to find the amount of radioactive substance present at time t. So this is half-life question. An exponential growth equation can be represented by that. Okay, so we have doubling and we have half-life, and we're using this for the next 4 questions. Okay, so our half-life and our doubling time equations. So radioactive substance loses 90% of its radioactivity in 200 days. An equation which could be used to determine the half-life. So if I'm determining the half-life, I'm solving for my period. Okay, so it's the number of times it takes for the amount to go down in half. So if I'm losing 90%, okay, losing 90% really means that I'm keeping 10%. So if I have 100% minus my loss, means I'm keeping 10% from case to case. So I'm starting with 100% and I'm going all the way down to 10%. So this will be my initial value and this will be my final value. Oops, I'll use an A for that. Okay, so let's just see if we can knock off some answers here. So final value is 10%. They didn't switch any of these to a decimal, so that's okay as long as we are consistent with what they did. So we're looking for a final amount of 10%. So I can knock off this and this as an option. I'm looking at an initial amount of 100%, and they both have 100%. So, okay, that's good. So we've got it down to 2 different options. Now, I'm trying to find the half-life. So if I go back up to my formula, you can't really see it there. I'm going to write it over here. It has an exponent. I'm just taking this exponent over here, t over h. H is the half-life. That is what we don't know. T is the time in days, which we do know is 200. And you can see that's the difference between these formulas. Which one is the exponent that we're solving for? So it actually is right here that is correct. This one here is wrong because they said the half-life was 200 days and you're solving for the time. So it is in fact A. Okay, in a population of insects, 32 insects increase from 500 to 500 insects in 25 weeks. The doubling time for this population of insects to the nearest tenth of a week. So we're solving for doubling time. So looking at my doubling time, let's write out the formula. So final amount is initial amount times a base of 2 to the t over p. Okay, so we're solving for the doubling time, which means we don't know this, which also means we know everything else. So we're going from 32 to 500. So we're ending at 500. We're starting at 32. And we're looking at a time of 25 weeks. And we're solving for the period. Okay, so to do this question here, I would probably just do y1, y2 intersect. So I'd put this one into y1. I would put this one into y2 and find out where they intersect. So let's go ahead and do that. Okay, so clearing this out, I'm going to have 500 in y1. And clearing this out, I'm going to have 32 multiplied by 2 to the exponent of, and I'll put this in brackets, 25 divided by x. And then close my bracket like that. Okay, so let's talk about a window setting. So we're going from 32 insects to 500 insects, and that is your y values. In 25 weeks, that's your x values. So my window for x, I'm going to go from 0 to 25 weeks, and we'll go up by, say, 5s. And then your insects, they're going up to 500. So we'll go 0 to 500, and we'll go up by, say, 50s. Okay, so let's hit graph and see what we get. There's the 500. There we are. So we want to intersect right there. So I'm going to go second, trace, option number 5 for intersect, and just press enter, enter, enter. You can see we get 6.3. So I go back over here, and my answer is 6.3. Okay. Cobalt is a radioactive isotope used in cancer radiation therapy. 10 grams of cobalt-60 decays to 4 grams in 7 years. The half-life to the nearest tenth of a year is what? Okay, so I'm decaying from 10 grams to 4 grams. So my initial amount is 10, my end amount is 4, and it's half-life. And it does this in 7 years. So again, we're solving for our unknown value here, our period, which is our half-life. Okay, so again, this is an example of y1, y2 intersect. I would do the exact same thing. So in here, let's clear everything out. So that's going to be 4. And here, clear that out. It's going to be 10 multiplied by half-life. So I'll just do 0.5. To the exponent of, and I'll put my exponent in brackets, it's 7 divided by x. And then close my brackets. So let's adjust our windows. Okay, so we're going 10 grams to 4 grams. So let's go from 0 to 10 grams, up by 1. Oh, that's the y values actually. Hold on. We're doing this in 7 years. Actually, that works for both because we're looking at 7 years and we're looking at 10 grams. So it works for both. So let's do that and then 1. Okay. So there's the 4 grams and there we go with the other. So we're going to find the intersection point and that will tell us our half-life. So second trace, option number 5. Enter, enter, enter. And there we go. I get 5.3. So 5.3. Okay, the value of a painting doubles every 20 years. Oh, that's a doubling question, so that's my period. Doubling is my base, so my base is 2 and my period is 20 years. If the value was 40,000 on July 1st, 2012, the approximate value on July 1st, 2000 was, so we're going back to the initial value. Okay, so it's kind of, it sounds like we're given the end value here, which is my end amount, and then I'm going backwards to find my initial amount. Okay, so let's put this into our formula. So I've got 40,000 equals the initial amount, which I don't know, times it is doubling time. And the distance between 2012 and 2000 is 12 years, and it has a doubling time of 20 years. Okay, so this one here is just a nice linear equation to solve. It doesn't look linear, does it? But this here is just a number. This is just a number that I can put into my calculator. So if I were, for example, multiplying that just by 2, I'd divide both sides by 2. So I'm going to divide both sides by 2 to the exponent of 12 over 20. Divide both sides by 2 to the exponent of 12 over 20. So that's gone. And then I just put this into my calculator. Okay, so 4,000. There we go. 4,000 divided by 2 to the exponent of 12 over 20. And I'll put those in brackets as well. Perfect. And there we go for the initial value. So 2,000, oh, just hold on a second here. Oh, I did 4,000. Let me just go back up here and correct that. I made a little boo-boo. Because I'm looking at my answers, I'm like, I don't have those as any of the answers. Well, that's because I didn't put the right amount in. Okay, so let me just insert another 0. There we are. 40,000, not 4,000. Okay, there we go. 26,000. I was wondering why none of my options were matching up. So 26,000, and they want it to the, let's see here. Oh, it didn't even say how to round it, but you can see from the options how we should round it. We should round it right here to 26,390. Okay, perfect. So let's just end this by doing a written response question. Okay, so we have grade 12 student correctly solves each of the following exponential equations as review for an exam. So problem number 1, 2, and 3. So they are correct solutions. In the student's original attempt to solve problem number 1, one error was made. The student's original solution is shown below. State the step in which the error was made. Okay. Oh, well, I see it right away. I've talked to you guys about this. Multiplying the 2 and the 4 together. You cannot do that because that is not a 4. It is a 4 exponent x. You can't multiply those together. So actually the mistake is made right in the very beginning. So you can't multiply a number by a base. I'm going to say a number by a power. Okay, that's the mistake. So let's correct the mistake on the next page here. So on the next page, they say to us, well, divide both sides of the equation by 2, and then algebraically, using a common base, show x equal to 2 is the only correct solution. So I had 2 times 4 to the x equals 32. So we're going to divide both sides by 2, and we get 4 to the x equals 32. Now they want us to do this with a common base. Oops, I didn't divide 32 by 2. 16. There we go. Okay, so they want to do this with a common base. So go to your smaller number, which is 4, and can you write 16 as a power of 4? And yes, you can. You can write this as 4 squared. So I'm going to have 4 to the exponent of x equals 4 squared. I drop my base, and I get x equals 2. Okay, now they say algebraically using logarithms, show that x equals 7.75 is the only correct solution to problem number 2. Okay, so problem number 2, if we go back here, was this. 2 to the x minus 3 equals 27. Okay, so let's write that out. So 2 to the x minus 3 equals 27. So whenever I have a power equal to a number, I'm not going to take the log of both sides. I'm going to use bay. So 1 power, use bay. So log base answer equals exponent. And then I would just add 3 to both sides. Obviously, you cannot do 27 plus 3. So this is log base 2 of 27 plus 3 equals x. Now, we want to show that that actually equals 7.75. So let's put this into our calculator. So log base 2 of 27, log base 2 of 27, and then I'm adding a 3 on the outside. And you can see that you get 7.75. So I know that I've done that correctly. Perfect. Okay, algebraically using common logarithms or a common base, show that x equals to negative 4/5 is the only correct solution to problem 3. So problem number 3 was this one here. So let's go back over here. So I have 9 to the x plus 2 equals 1. Oops, what happened there? Let's try that again. Oh, I see. I moved the whole thing. There we are. Okay, so 9 to the x plus 2 equals 1 over 27, all to the x. So I'm not going to use logs because then I'm going to have to take the log of both sides, bring the exponent down, and that's quite a process. So I'm going to use common base. I think that would be easier. So 9 and 27, go to the smaller, which is 9. 27 can't be written as a power of 9, so go even smaller. So I know that 9 is the same as 3 squared. And 20 is the same as 3 cubed. But it's not 27, it's 1 over 27. So remember, when we have a 1 over, that's a reciprocal. So to show that when I have a fraction base and I want to write it as a whole number base, just make the exponent negative. So this will be the same as 3 squared to the x plus 2 equals 3 to the negative 3 to the x. Okay, so let's multiply these together, multiply the exponents. So 2x plus 4 equals 3 to the negative 3x, and then I will drop a base and make them equal. So 2x plus 4 is the same as negative 3x. So what I'm going to do is I am going to subtract 2x from both sides to get my variable on one side. So I get 4 equals negative 5x, and then I'm just going to divide both sides by negative 5. And I get that x is equal to negative 4/5. So that would be your correct solution. And we showed that we got the right one. Okay, well, I hope this video helps you guys going through the practice test, and I'll see you for the next video.